Hello viewers, another interesting trigonometry equation. We're looking for the values of x that satisfy this trigonometry equation, and x has to be in the interval minus pi to pi. So here, what do? We can solve this we can divide both sides by cosine so that we convert it to tan. So this becomes, we can write this as tan x over 2, or let's just say divide both sides by cosine x over 2, and also here divide by cosine x over 2. What does that mean? It means we are assuming that this cosine x over 2 is not equals to 0. So here this will become just tan x over 2, it's equals to 1. Now, what is x over 2 not equals to 0? This means x over 2 should not be what? 90 or n pi or plus n pi, because this will give you the zeros of cosine. Yes. So in other words, it means x should not be what? If you multiply both sides by 2, x should not be pi plus what? 2 n, yeah, multiply this by 2, you have pi, multiply this. So this is saying x should not be this. All right, so let's see. Um, if we solve this now, let's concentrate on this one. This is 1, so we know that we're either in the first quadrant or in the third quadrant. Why? Because tan is positive in this quadrant. So we will have like an angle in the first quadrant whose tan is equals to 1 is nothing but what? Pi over 4. So let me call this my x star. So an x star is an angle in the first quadrant whose tan will give us 1. So if we are in the first quadrant, we are fine. In the first quadrant, it means this x over 2 is just going to be this pi over 4. Then I can add 2 and pi, no problem. It will work. Now, or if we are in the what? The third quadrant, our x over 2, which is this angle, is going to be, you need to add what? You need to add pi to this pi over 4. So this is 5 pi over 4 because we are in the third quadrant. And I can still add 2 and pi. It's not a problem. So from here, what is x? To get x in this equation, I have to multiply both sides by 2. So x will be pi over 2 plus what? Let's say 4 and pi. And here also we'll have x is what? 5 pi by 2 plus what? Plus 4 and pi. All right, now we need to consider our interval. The interval we need is minus pi to where? To pi. So it means something like this. Let's say, yes. Now, let's see, it means we can take n to be from minus 1. Since we have a negative number here, we can start with minus 1. So if n is minus 1, now if you put minus 1 here, we're going to have pi over 2 minus what? It's going to be minus 4 pi, which is what? Which is like 8 pi over 2. So you're going to have minus 7 pi over 2. Now, if you look, minus 7 pi over 2 is not in this domain here because we need minus 5 pi. We need minus from minus pi to pi. So usually I use the coefficient of pi to see what is the coefficient of pi here. In this case, it's minus 1 to 1, right? But what is the coefficient of pi in this case? If you have minus 7 pi over 2, the coefficient of pi is what? It's minus 3.5, which is already outside somewhere here. So it means we cannot take this one. And similarly, if you try it here in this second case, it's going to be the same. So you have 5 pi over 2 minus 4 pi, which is 8 pi over 4, uh, which you can write as what? 4 pi you can write as what? Over 2, right? Yes. Okay, so this will give you minus 3 pi over 2. So minus 3 pi over 2 is also outside the range. So you cannot take any of it. Now, so it means it's not going to work for n equals to minus 1. So we are left with what? When n equals to what? So we go with n equals to 0, with n is equals to 0. So if n is equals to 0, what do we have? Now, don't forget, I said if n is equals to minus 1, what did we get? We got minus 7 pi by 2, and we got minus 3 pi by 2. And we said we're not going to take any of this. If n is equals to 0, we're going to have just pi over 2 and what? 5 pi over 2, right? But you can see that 5 pi over 2 is also outside the range because we need just to where? To pi. Look at the coefficient here. 5 over 2 is what? Is about, it's 2 point something, right? Oh, no, not 5 pi over 2. Yeah, 5 pi over 2 is about 2 point something, which is actually greater. So we are not going to take, we're not going to take these as well. So this is not going, this is not going. So the only good one here is what? Is pi over 2. So now, so far, our solution set is just what? Pi over what? Over 2. Now let's return back here. Look at here. Here we said x should not be what? Pi or 2n pi. So, and fortunately, we don't have it inside here. We don't have any of this inside the solution set. So, we said the solution set is just pi over 2, right? Now, don't forget that here we mentioned something, that x is not pi plus 2n pi. Unfortunately, if you look into this, you will see that we don't have pi or plus 2n pi there. Now, in a situation where you even have it, for example, if you have, let's assume you have pi in the solution set, it's not enough. Because of this condition, it's not enough for you to just discard that. You need to go to the original equation and test it in the original equation. If it satisfies the original equation, fine. Then just leave it in the solution set. It means this condition should not be considered. So it means the equation still hold even with this condition. So, but in this case, there's no problem. We just have pi over 2, so we're fine. Now, let's try to see to solve this same problem in another way using another method. Now, don't forget, we are solving sine x over 2 equals to cosine of x over 2, and we're looking for solution in this interval. Now here we'll use the half angle formulas. So this is going to be plus minus because we are not really sure of the quadrant of x over 2. So plus minus is fine. So this is 1 minus what? Cosine of x. Is it cosine over 2, right? Then this also the same story here. And this will be 1 plus cosine of x over 2. So this now becomes a radical equation, right? And how do you solve radical equation? Here the index is 2, so we can square both sides. So we square both sides, we'll just have 1 minus cosine of x over 2. It's equals to 1 plus cosine of x over 2. We can cross multiply so that you have 2 minus 2 cosine of x is equals to 2 plus 2 cosine of x. So 2 will go with 2. We'll have minus 2 cosine of x. It's equals to 2 cosine of x. So we can take this to the other side. So this becomes 0. It will now become 4 cosine of x. which we can easily write as cosine of x is equals to 0. So that's when divided both sides by 4. And this means that x is equals to what? Pi over 2 plus what? Plus n pi. Is that okay? Now, can we take n to be minus 1? Let's take n to be minus 1. Why? Because we have negative here, negative pi to pi. So if you use the coefficient of pi, let's say minus 1 to 1. So you can start from that. So let's see. If n is equals to minus 1, what is x? X is what? Is going to be pi over 2 minus pi. So you have minus pi over 2. And if n is 0, if n is 0, what is x? X is just pi over 2. And if n is 1, we're going to have 3 pi over 2, which is already above the interval. So it means we have this one. What do we have? Minus pi over 2 to pi over 2. Now, is there a problem? Okay, yes. So you can see using the first method, we got only pi over 2. So why do we have minus pi over 2 and pi over 2 here? If we remember in pre-calculus 1, anytime you are dealing with a radical equation, what do? We square it, or we what? We take the power. For example, if we have index 3, we'll cube both sides. You can see from here to here, what did we do? We squared both sides. So it means that you can get a solution which does not satisfy the original equation. So this solution we got now here is not the solution of the original problem. It's the solution of this one here after squaring both sides, right? So it means we have to test this solution to see, do they actually satisfy the original equation? Now, any solution that does not satisfy the original equation is considered as an extraneous solution, and it has to be discarded, right? So now let's check. We will check. So remember, which one is the problem? The 1 pi minus pi over 2. So remember, we want to have this one. We want to show that this, or we want to check if this is true. So if you take x to be minus pi over 2, what do you have? You have, put x to be minus pi over 2. Minus pi over 2 divided by pi over 2, you have minus pi over 4. And on the right hand side also, you will have the same thing, right? But sine is odd, so this becomes minus sine pi over 4. Cosine is even, so this becomes just cosine pi over 4. So what do we have here? This would be cosine pi over 4 is the same thing as cosine 45, which is root 2 over 2. And here cosine 45 also is root 2 over 2. So you can see that these two of them are not equal, because on the left hand side you have negative, on the right hand side you have positive. So it means that this is not a solution. So minus pi over 2 is an extraneous solution, so we need to reject it, right? So it means we still have only pi over 2 inside here. Now, we can also check the pi over 2, but I think obviously if you check pi over 2, it's going to be the same, because you're going to have sine pi over 4, which is still going to be the same thing as cosine pi over 4. Yes. All right. So I hope this is clear. So if you have not subscribed to my channel, kindly do that. And also share this videos with your friends. Thank you for watching.